Okay, so I think it's time to start. Okay, so greetings everyone. I hope you're all doing well and staying safe. I am Zakaria Maradi, a master degree petroleum engineering student at Boumediene University, and I will be your moderator for today's session. Our SP University of Boumediene Student Chapter is honored to host distinguished lecturer Mr. José Carlos Bruno, who will be giving a webinar about human factors improving performance for safety and operational excellence in the oil and gas industry. Mr. José Carlos Bruno is a senior engineer with over 35 years in the oil and gas industry. His experience includes several top management positions at Petrobras, both in Brazil and overseas, mainly in offshore exploration projects around the world, including Africa, the Middle East, the Gulf of Mexico, the Caribbean, and Australia. Back in Brazil in 2015, in a bold shift in his career, he decided to work as a human factors leader to help Petrobras and the industry to incorporate its principles and concepts into the traditional way of doing things. Mr. Bruno has a Bachelor in Engineering in Civil Engineering at the Pontifical Catholic University of Rio Grande do Sul State, Brazil, a post-graduation degree in Petroleum Engineering at Petrobras University, Brazil, an executive MBA at INSEAD, France, and a master's degree in Human Factors and System Safety at Lund University, Sweden. At the SP, he works as a Director Communities Liaison for the Human Factors Technical Section and has been recognized as distinguished lecturer for this 21-22 seasons. Now, without any further ado, please welcome with me Mr. Bruno. Thank you so much for making the time for us today, and the mic is definitely yours.
Hey, thank you, everyone. Thank you for the SP student chapter over there. So for me, it's more than an honor. It's always a pleasure to be able to speak with students in the petroleum industry, because you guys are the future of our industry. And this topic, the new view of human factors, is definitely something that you have to focus from now on. So if you want to become a much safer industry and much more operational excellent in the near future. So then we'll see during this presentation that we are safer than ever in the industry. We are highly safe industry, but it's not enough due to the high hazardous operations you conduct in our industry. So then we have to become what we call ultra safe industry. So it will require a big change in our mindset. So everything you learn over the years now is being challenged. So then that's part of this presentation. And also, this is very similar to the presentations I've been delivered over the last year into this distinguished letter program to several different sections around the world. For instance, in last February, I went to Africa in a tour through several countries in Africa to deliver the same presentation in person. It's a wonderful experience, you know, how people are very interested in this topic recently. So then thank you for the opportunity, and hopefully we'll enjoy as the way I enjoy the subject after the presentation. So the total length of the presentation is less than 1 hour. And I believe that afterwards we'll have a Q&A session, so then I can explain a little further any doubts, any questions that may be raised, okay? So let's go on. The new view of human factors. So what exactly is that, human factors? Because this is quite new for the oil industry, and because of being new, it's still some confused and quite mysterious, you know, to some of our professionals in the industry. So let's start trying to share some basic understandings about human factors, what in fact human factors is. So, but first, although as I said, so it's quite new in the industry, as I see in scientific field, it's not that new. So a scholar says that the concepts of human factors started long ago during the World War II. And this particular event called the belly flop problem is for many of these scholars the beginning of everything. So when people, when organizations, when science started to understand that labeling a failure as a human error is not enough to explain what happened in very complex activities. So for instance, this plane, the B-17, an iconic bomber, American iconic bomber during World War II, started to present some problems. After coming back from Germany, from bombing Germany, finalizing the mission. So when the pilot is parking the plane after landing in UK, so inadvertently, instead of retrieving the flaps, the pilot wrongly retrieved the gearbox, the landing gear. So then the problem is the plane fall down and with a total loss. So the approach to trying to resolve the problem was the very traditional one. So they retrain the pilots, they punish the pilots, they replace the pilots, and the problem continues up to 460 times. So 406 different pilots did the same thing. And one engineer called Alphonse Chapanis realized that they had a design problem in the cockpit. You know, the two levers, the flap and the landing gear, are very similar and close to each other, side by side. So instead of changing the design, because there is wartime, so it would not be possible, they simply decided to put a flap-shaped device on the flap lever and a wheel-shaped device on the top of the landing gear lever. The result was that after only doing that, the same problem never, ever happened again. So this is an indication that human error might be connected to everything else that surrounds us. So and then this is the beginning of the understanding of system thinking. So we have to look to the system and how humans interact to each other and with the other elements of the system, how these dynamics of the systems working may help or may hinder safety. Okay, so this is the very beginning of everything. So if you have the opportunity to look at the Google up, you know, to take a look on a modern cockpit, you see that even today, the landing gear has a wheel shape on the top, and the flap has a wing shape on the top. So this is kind of so iconic to the aviation that they keep the same thing, although it's no longer necessary. So in few words, human factors, actually, it talks about the factors that influence our performance, what we do. So a lot of factors are involved on that from different scientific disciplines, mostly social disciplines, but also medicine, engineering, organizational studies, and so on. So then there are a lot of disciplines that compose this field of scientific field that we call human factors. And when we're doing anything, these factors are influencing what we do, from social sources, psychological, physical, organizational, whatever influences the decisions we make when I'm doing anything, not only in the job, not only our job in the work, but also everywhere, even at home. So we are always being influenced by all these factors surrounding us. So after this presentation, if anybody approaches you asking, you went to that presentation about human factors, what exactly does it mean? So easy. Human factors is just everything that influences human performance, period. So this is the simplest way of explaining human factors. Whatever influences what we do, we can call human factors. Okay, so human factors is not the plural of the human factor, the individual problem, as we use it to think in the past. Human factors is a combination of human as the center of the studies and factors that everything that influences the human that is the center of the system. Okay, this is the very simple definition of human factors. And just to let you know how difficult it is to understand, how this can incorporate to the way we think, the way we do things today. So a simple question may challenge what we think. Why do accidents happen in our industry? Just think for yourselves. Why do accidents happen in our industry? The answer to these questions may be quite different, and the difference will represent the way we manage safety in the oil industry. If, for instance, if you believe that in the traditional view that people are the problem to control, because we believe in the traditional view that the unsafe choice of people may cause accidents, then logically, the entire safety system in the oil industry will focus on people's behavior, trying to control or even adapt or change people's behavior in order to achieve safety, because we believe that people are the problem in the system. Because we believe the assumption is that the unsafe choice of people cause accidents. So, and when you look at this way, so another side effect, undesirable side effect appears. The entire learning process is reactive. Why I'm saying that? Because if you believe that you have a very good system, close to the perfection system, and the problems are the people that are doing things that they're not supposed to do, the only thing I need to do for learning is see when something goes wrong, see what somebody did wrongly, and correct it reactively. Because we believe that if they have followed the procedures, if they had followed the rules and regulations, so then things will ended up okay. So that there's no need of learning from when everything goes okay. So then we learn when something goes wrong. That's why we say that we have a reactive learning in the traditional view, which is overwhelmingly predominant in the oil industry. Most of our organizations still believe in this traditional view that the literature calls the old view, as you can see when you look at in the literature. Another way of viewing the work is called the system view or new view. That is proposed by this new view of human factors. So we understand that choices people have are determined by the constraints in place. So peoples are always trying to reconcile what is possible to do with what is desirable to do. So this is a daily fight, daily negotiation, a daily trade-off. People are always surrounded by different types of constraints. We'll try to explore a little bit further during this presentation what does it mean. So then when you will realize that, so the focus shift from people for the individuals to the systems. The constraints that are there in the systems, we have to identify the constraints, the limitations, and try to overcome these problems. So together with people. So then we have to learn how the organization is assembled, how the work is organized, so the organizational factors. And to be able to do that, necessarily, we'll have to learn proactively. So have to interact with people in a daily basis and start learning, not from problems when something goes wrong, but to have to learn in the normal work when everything seems to be okay. Because the same failures, I will explore that a little further later, the same failures you have when you have an accident are there when you have everything okay. So it's just a matter of take a look profoundly with a systemic view, then you'll find this and correct proactively before we have an accident. So in a system view, we will say that people was never a problem. People are not a problem and they will never be a problem. People are the solution of the normal problem you have in our very complex systems, especially in the oil industry. Okay, so we're talking, we can talk about human factors without talking about safety. because as at the end of the presentation, you'll see that human factors surrounds, encompasses almost everything we do, but focus on safety. This presentation focuses on safety. So let's see how the oil industry sees safety, okay? But first, we have to define safety. Let's take on two very different definitions about safety. In the traditional way, safety is seen as the absence of negatives. It means that if you don't have accidents, so then we have safety. If you have accidents, then we don't have safety. You can see that this is not the definition of safety, it's just a result of having safety or not having safety. So this is the traditional view of safety. The new view proposes that safety is something else. Safety is all the presence of all the positive capacities in our system that will allow us to have a better result, or we have safety. We have something different from what we have today. So then, if you want to improve safety, we have to take a look inside the system, what to have in place, what are the conditions you have in place that will help us to escape from accidents or reduce the chances of accidents or improve the chances of having everything going okay, rather than just measure the results and call that safety. So as you can imagine, the oil industry sees safety as the absence of incidents. That's why you have all these charts. This is IOGP's 2021 chart, total recordable injury rate. So over the years, the last 10, 11 years. So if you look at this, so then we can say that believing that the number of incidents measures safety performance, we can say that 2020 is much safer than 2011. This is just taking a look in a cold way to this chart. There are two big problems in this chart. The first one, a low number doesn't mean that you are working safely. We can work 5 years without a single incident unsafely. There are a lot of factors that influence the final result. If you don't look inside the system to see what to have in place, we cannot categorically say that we are safe just based on the numbers. Okay, a lot of other issues influence the result, and the main of them, I can assure you, are the way people deal with the uncertainty, with the unsafe situation. So people are creating safety, even if the environment is not as safe as it should be. Okay, so that's what we have the result. And in the oil, there's a second problem in the oil industry, because fortunately, we have very fewer process accidents or operational accidents if compared with occupational personal accidents. So there's a tendency of our leaders to project the result of occupational safety into the operational safety or process safety, which is very dangerous because they are very different animals. The way we deal and manage occupational safety is quite different from the way I should deal and manage process and operational safety. So, and one of the reasons of that is that old beliefs about pyramids and so all those stuff, all those fallacies that we had created in our minds in the past. So if you reduce the base of the pyramid and you reduce the top of the pyramid, which scientifically could never be proven. Okay, so then it's it's not part of this presentation because we will require a total presentation dedicated to this, but just to have this in mind. So there's another way of looking at how safe we are in the industry, proposed by a scholar called René Almaberti, one of the top guys in the human factors organizational safety today. He proposed a different way of looking at how safe we are when he categorized the different human activities based on the risk of fatalities. Okay, so then in here we can see that we can categorize activities from very unsafe, chances of fatality higher than 1 per 100, 1 per 50. It's like Himalaya mountaineering and some other, sports like that. So very unsafe. So, and if you go all the way to the right, so then you have the ultra safe activities represented here mostly by civil aviation, or Western civil aviation, and the nuclear industry. So these are ultra safe. The risk of fatality is lower than 1 per million. Okay, and we, the oil industry, we are here right in the middle, as most of the other activities considered safe. So it means that the risk of fatality is something in between 1 per 1,000 to 1 per 100,000, but in average 1 per 10,000, which is far away to the level of ultra safe. 1 per 10,000, 1 for 1 million. It means that, we have a long journey ahead if you want to become ultra safe, an ultra safe industry. So, but being safe, this is the main features of being safe, and it's not only the oil industry, but most of the human activities. Safety is always declared the #1 priority. Whenever you ask any leader in the oil industry, for instance, what is your #1 priority as a manager? The answer will be safety. Okay, this is something they have in mind, and they are, of course, highly committed to safety. There's no doubt on that. But the focus is mostly on compliance and controlling, eliminating at-risk behaviors. Remember, because we believe that humans are the problem, human behavior is the problem. So then you have to control human behavior if you want to achieve safety. Okay. Another thing is that the safety normally is approached on technology. We are replacing people by technology, or even worse, this is good. But the worst way of using technology is using technology to control people. Controlling people is an idea of the 18th century, and we are applying 21st century technology to practice 18th century management. Okay, management system audits, tons, millions of audits, and enforcement. So this is a main feature of a safe organization where our industry is placed. So, and all those activities show the same type of chart that we've seen a few slides ago. So low accident rates is near to zero. Okay, this is the reality. The problem is being safe is not enough, because we deal with a very dangerous activities. So then can result very easily in catastrophic events. So we are highly hazardous and very complex industry, which means that a minor mistake, a minor issue, a minor error can escalate and interact with other events, and very easily ended up in a catastrophic event like the ones that you've seen in these pictures. So we need to do something else. So we cannot be comfortable just being safe. Another way of looking at that chart I've shown you is this prepared adapted from Decker, another very renowned scholar in this human factors field, when he says that the more complex the system is, the less the effects of rules. So in highly complex system, rules will have very little effect. Why? Because of the uncertainty, the residual uncertainty, or the residual risks of this kind of operations. So in this type of high risky, complex operations, we need a little more flexibility. We need to count on people taking decisions at a very critical moments. So, and doing safety is not doing the right thing, doing things right, but actually is doing the right thing the moment is required. So then the safety effect of additional operational safety rules decreases when we goes from the very low level of safety and start doing something differently. So the oil industry is right here in the middle. So it means that everything we did in the past to bring us to this level now must be let's say, challenge, because a lot of important things was lost doing that. The moment you control people, impose things, enforce things, the most important element for the future is lost, which is trust. Now we need to recreate trust. And how can you do that? Because over the years, we control people, we punish people, we create an environment of very limited psychological safety. So people are afraid. So we have an environment of a low level of psychological safety. People are afraid of speak up and so on. So then people silence. Then we need to bring people back. So we need to, again, rebalance, the scale. And of course, we need rules, we need regulations, we need procedures, but we also will have to rely on the expertise of people. So how can you balance that to become ultra safe, an ultra safe industry? You see that during the presentations, I will show some books and something. At the end, I will show you a lot of different books. And I will send after the presentation a book list as a reference to you for the one that want to go deeper into this idea that I'm presenting here today. Okay, don't be afraid. So by doing that, so then how can you move from the level of safe organization to the level of becoming an ultra safe organization? So what we're doing is, let's take a look on what the others are doing, special civil aviation, nuclear industry, what they're doing differently. We don't need to reinvent the wheel. We can take a look on what they're doing and perhaps take some ideas and try to translate into our own reality. So, and start not from zero, but it starts from something else in the middle. So they had both civil aviation and nuclear industry, some, as I call, catalyst events during the 70s and 80s, mostly 70s, that started a huge work, not only the organizations, but the scientific field, academics, and so on, trying to understand the role of human error into these big accidents. In here is represented by the Tenerife accident. Is still today the worst civil aviation catastrophe in terms of fatalities, 583 fatalities in this accident when the two jumbo jets collided in the runway in the Tenerife airport in the Canary Islands in 1977. This was the beginning of what we call today the CRM, the cockpit results management. At the time now is the corporate results management in the oil industry. And this was even more alarming. The 3 Mile Island incident in 1979 in the nuclear industry this is in the East Coast in the United States, when this 3 Mile Island power plant, the reactor number 2, almost melt down. It would be enormous catastrophe. Then it's alarming everybody. So from 1980 on, so the elite of scientists and organization managers and leaders and everybody else start to get together, to try to understand what we're doing. It seems that we are not able anymore as human beings to deal with the enormous amount of energy we are dealing today. So what can you do? And the simple explanation up there, blaming human error for everything, was not enough. So then the first thing they start to do is to demystify human error as a cause of accidents. So this is the first, uncommon idea from this new view. Human error is never a cause of anything. Human error is always a consequence of deeper problems in our systems. So keep this in your mind. So human error has been demystified as cause of accidents. So by doing that, so they could start adopting a system view. So then we have to open our minds, change our glasses or our lens and try to take a look into the real world, with all the opportunities you are missing when you only focus on humans and human error as the main cause of accidents. So then you you see that the world is much more complex than we believe it up to this time. So then adopted a system view. And today, these kind of activities, ultra safe organizations, are also called high reliability organizations. So that is our goal as an as the oil industry as a whole, is to become high reliability organizations or ultra safe organizations. Okay, we had our opportunities as well. So the same times, so in 1988 or more recently in 2010, we have some big events that could act as a catalyst events. So the problem is they didn't. What we have learned, according to Andrew Hopkins, the author of this book, it's highly recommended for anybody that wants to join the oil industry. Read this book, Disastrous Decisions. So this is so far the only premium book that try to understand or explain the Deepwater Horizon accident from the perspective of human and organizational factors. Okay, the only one. So just to have an idea about how little impact, you know, these big accidents had in the way we think safety in a structural, in terms of a structure. Okay, we had made a lot of changes from Piper Alpha and Deepwater Horizons, but mainly on procedures, on equipment, on regulations, and so on. But in terms of big change in our mindset, we're still in the beginning. So that's why few years later, the same author, Andrew Hopkins, an Australian researcher, said that we, the oil industry, will never be high reliability organizations if you still rely on campaigns to change hearts and minds on the operational front line. Basically, what we do in our systems is asking people to pay attention, you know, to care of each other, to follow the rules, to follow the procedures. So putting everything in terms of safety on the shoulders of people over there at the front line. So, and these hearts and minds campaigns, so that we can name a lot of them. So like hands and fingers campaigns. Every year we have a kind of hands and fingers campaign in the oil industry with no results at all. So it means that probably that's not a good approach. You have to do something differently. They have to take a look on the system, not the individuals themselves. Okay. So they even say that instead of that, we must identify the obvious precursors of the next catastrophe and get serious about eliminating them. So that you have to learn proactively. You have to try to find out together with our workers, where are the problems in the system that can lead, if interacting with some other elements, to a big catastrophic event. So then and eliminate them. We have to be very focused on that. So rather than just controlling people's behavior, that's a big change in the mindset. It's not easy. Okay, so the traditional approach, in summary, says that if you follow the rules, we'll succeed. If you don't follow, we may have problems. So this is a very mechanistic view. So then when you believe that failures are the result of erratic behavior or unreliable people in a safe system. The system is safe, just follow the rules, everything will be okay. So that's because we just trying to learn when you have an incident or accident, because there's no need of learning when everything goes okay, because we assume that it was okay because people just follow the rule. That's what we call work as imagined. We believe that. That's not the way work is actually done, but we don't know that because we don't interact with the reality in an everyday basis, as we should do. Okay, so this is what Eric Honagel, another important scholar, calls safety one, the way avoiding things to go wrong. So we just trying to learn to avoid the repetition of something that went wrong. So that's safety one. It's important, but not enough. Okay. At the end, we have this, a very bureaucratic system, totally focused on people at the front line, you know, asking them to work safely. So just have a safe day, which is wonderful, but says nothing. Okay. So then we have to do something else. We have to work on the system. We have to work on the conditions to the job is done, to facilitate the worker's life. Today, all this very highly bureaucratic system do not facilitate anything. On the contrary, they create problems to everyday work. And we have some side effects, like Decker has gave us some examples in his book, 2015 book, Safety Differently, is in the list I'm going to send to you. For instance, we have a visible growing bureaucracy with a visible growing the money we spend to control everything. Because in a complex system, it's impossible. Controlling everything is impossible. So then we are fighting against an enemy that you cannot win, because we cannot control everything. We spend lots of money, and with several doors still open for an accident. We have to start to trust people to fill in the gaps in our normally imperfect system. So then another side effect is the numbers game. So that if you want to have zero accidents, which is virtually impossible, then we'll have zero through numbers game. We have to survive. If you don't have zero, you lost the next contract. So then we better have zero, even though this may represent that something is going to be concealed under carpet. Okay, numbers game is another consequence for this kind of approach. It provokes organizational silence, so people are afraid to speak up, because otherwise they may lose the job. For instance, who in our industry is confident enough to raise his hand or her hand and say, "Hey, I made a mistake that created a problem"? Nobody, because most likely this one who's going to be fired. So then they keep silent. So and it's just waiting and praying that nothing goes wrong because of the mistake. Okay, then we miss an opportunity to understand the problem and correct the problem. And this is what happens. So people disengage. So if you just follow the rules and that's it, so then let's do that. Even though I'm seeing that something is going to be wrong, it's not the best way of doing things, but I cannot speak up. So then let's do what they expect me to do to keep my job. So then the disengagement, another side effect we have in this kind of approach. Okay, but the oil and gas industry is very different from the linear, very simple activities. The other industry is highly complex social technical system. Social because no matter the technology we operate, no matter the state of the art of equipment we manage, we still need people to connect everything. Without people there, the state of the art technology and equipment so on wouldn't work. So then we need people. That's why we, especially during the very critical moments when the system is not enough, the algorithm is not enough to take the right decision. So then we need to have people there to take an unconventional decision when necessary. That's why you call that social technical system. And this kind of system demands a totally different approach to cope with its complexity. I like this cartoon because it gives us a very simple and amazing understanding about what I'm saying. So in the traditional view, we are being told that, so if you follow the rules, you ended up okay. So then if you want to do something from A to B, just follow the procedures, the plan and everything else, and we'll end up okay. But in the real world is not a straight line like this. So the real world is like this. In a complex system, we have numerous, almost infinite ways of doing something depending on the circumstances. So the art is we have to be able to choose the best possible way to go from A to B, considering the reality. It's not an easy task. So, but for sure, that will never be this one. It's going to be one of these. And most of the time, we choose the right one. Sometimes, because it's part of the game, we fail. So this is the reality. So, because we introduce the concept of complexity, and to be able to cope with the complexity, we have to enhance our focus and take a look on a system rather than individual elements, on individual parts of the system, mostly individuals, human beings, and take a look on the system, how the system works, interact with the elements of the system interact with each other in a dynamic way. So this is a very simple explanation of the difference between the work as imagined, A to B, and the work as done, the reality, which is much richer than what we can imagine, what we can write down in a procedure or in a plan or whatever. So reality is much more richer, is much richer than this. Okay, so in a system view, especially in complex social technical systems, so we understand that there will be always residuals of uncertainty. This is the main characteristic of a complexity. So uncertainty, we cannot anticipate everything. We cannot control everything. We cannot be prepared for everything in advance. So this is, how can you deal with this uncertainty when something that is not planned or is different from the way we have planned simply happen? Well, we have to adapt. Adaptations are a necessary element in a complex system to cope with the normal variability. That's what we call, people have to vary their performance variability. So adaptations that in the old view we call deviations, violations, are not else than something as necessary measure that people take to be able to cope with the complexity. And the human being is the only element that can adapt. The other elements are designed to be highly efficient. So the humans are the ones that are not reliable in this sense. So all the elements are highly reliable, but on the sense that reliability is an element has to perform the way it's been designed for the lifetime is being designed, so the same way all the time. So humans are not this way. So humans vary, and because of this unique characteristics of a human being, humans are the only element in the system that can adapt to the circumstances, to the normal variation you have in the system. That's why we say that people are the most important element in a highly social, technical, complex system, because systems are not inherently or automatically safe. So humans create safety in an everyday operations. We are always creating safety, filling the gaps that any system has normally. So because of this kind of imperfection, a normal imperfection of the systems. And people are always doing their best to reconcile these conflicting goals simultaneously, because we must be efficient, productive, deliver high quality services or products, and we must be safe all the time. So that's why we cannot say that safety is the #1 priority. It might be sometimes, some other times production might be the priority, some other times efficiency, and some others quality, and so on. So that's what Eric Honago calls the ETTO principle, or efficient thoroughness trade-off. We are always trading off which one will have the #1 priority in the moment. We do that every time. At the front line, in the board of directors of any organization. So any human being does the same thing every time, even though we don't realize we are doing that. Yes, we are doing. We are always measuring the cost benefit of everything and taking the decisions. As I said, most of the time we succeed. 99.99% of times we succeed, but sometimes we don't. Okay, this is normal. Okay, that's why we say that humans create safety in everyday decisions they take. So that's why humans are the most important element in any complex system. So humans creating safety in a daily basis help us to fill up the gaps normally existent in our systems. But in here, we may have a paradox. Although we are the most important element to adapt to the normal variability of a system, we make mistakes, a lot of mistakes. So, but when we start to understand that nobody comes to work to do a bad job, so then we can start to understand that mistakes, although normal, might be something that is inherent to the reality. So then we can start developing or designing systems that take this into account, okay? Because we do lots of mistakes. We make errors a lot of times. So then because we are humans, this is inherent to being human being, okay? So because we do what makes sense to us at the time we decide to do. So whenever we start to trying to understand why an error happened, so we must find the sense making behind the story. Why people did what they did. What did make sense to them the moment they decide to do that way rather than the other way. So then we can explain the reasons behind the error. Remember, as I said in the beginning, error is not the cause of anything, it's a consequence of something you have in your system. So whenever investigating anything, so we have to go after this response. Why such thing made sense to those people at that time, okay? Because we know that error is normal. We're not normalizing error. We're just admitting that we make errors. We are human beings. The best of the best professional sometimes makes error. The best of the best athlete, the #1 in the Olympics, sometimes also makes mistakes. It's part of the game. The moment you understand that error is part of the game, error is never a randomic, a spurious element in a perfect system, and start to understand that error is part of the daily routine in a normal world, in the real world. So then we can start building systems prepared to deal with human error, better prepared to deal with human error. Because we say that error is normal because whenever we do anything, so error is always a possibility. So we always make mistakes. I don't believe that anybody in this audience never made any mistake in the past. We always make mistakes. So and this possibility of making an error dependent on the error traps we have in our systems. So error trap is any condition that influence us to make mistakes. So that's why we call these error traps as performance shaping factors. And I can assure you that in our systems, we have lots of error traps. Here in this slide, I have some examples, but we can fill up 10 slides with other examples. Complex procedures, multiple conflicting goals, harsh environments, bad designs, ambiguities, boring, trivial, repetitive tasks, time pressure. You know, the oil industry is based on time, you know. Everything is measured based on time. The scarcity of resources, we don't have resources for everything, so we have to deal with that in a daily basis. Poor communication, confusing displays or controls, all of them are error traps that can influence the possibility of committing a mistake. So if you want to start improving our level of safety, I would say that we better stop trying to control people's behavior, and let's just try together with people, try to find out where we have these error traps and identify and eliminate them. We'll be much more efficient in terms of improving safety. So in summary, in system view, there's no that mechanist view. So we have in everyday work performance variability. We are trying, whenever we do anything, to do our best, depending on the circumstances, the knowledge we have, the information we have, the resources we have in place. So then we all the time are trying to do our best. most of the time we succeed. So with no adverse events. But sometimes we fail. We have accidents or incidents. Then we start to understand that both success and failure are possible results of all these countless interactions and performance variability in daily work. So in this case, understanding that the same problems we have here when we go wrong, we have here when you go right. So then we better proactively start trying to understand why, even though the same problems we have here didn't lead us to an accident. Why? What additional positive capacities we have in here that helped us to, even though we made the same mistakes we did here, we succeed. So then that's why we have to learn from the normal work instead of just learning when something goes wrong. That's why Edgar Honagel calls safety 2, making sure things go right rather than just avoid things to go wrong. Or as Todd Conklin, another very important scholar says, calls the pre-accident investigations. Let's learn before we have an accident rather than after having an accident, okay? So this is a totally different approach. It's not easy because you have to interact with people. Remember, safety is not something we do for people, it's something we do with people. We have to bring them back, so, and be part of the game. So, as I said in the beginning, so we may have lost the balance. Of course, it's very important, as Alberti, the same guy that designed that chart with different risks of fatality, calls controlled safety. Of course, we need to have regulations, procedures, rules, and so on to be followed, you know, to be able to have a level of ultimate safety in our organization. But on the other hand, so we need to have to regain, you know, trust of people. We have to rebuild the trust on people. So what he calls managed safety, based on the expertise and experience of workers. We have to have a balance. Sometimes, yes, we have to follow the rules strictly, but sometimes we have to rely on the expertise and experience of workers, you know, to be able to deal with this normal variability in a highly complex system. So the new view in short says that human error is not the cause of anything. Rather, human error is always connected to the way the work is organized. So to the limitations you have, to the constraints you have, to the process the way it is, to the organizational culture. Human error is always connected to something else. So then we have to take a look on this something else, because human error in this case is rather a symptom of problems or troubles you have deep inside in our system. So let's take human error as an information that you have to deal with and have to learn with to be able to fix the problem into the system, to reduce the possibility of human error either happen or if happens, not to escalate to an accident. Okay. So because complex systems embody reconcilable conflicting goals that only people can resolve in a daily basis operation. So some of our leaders don't know that, even don't agree with that. So, and what I say to them, so go there, take a look on yourself. You'll see that this is not in a theory. This is not a hypothesis. These are just the explanation of the facts over there. Okay. So then at the end, we say that safety is not in existence of negatives, but the presence of positive capacities that safeguards or controls that will make things to go right most of the time. So that's will increase the resilience of the system. So, and at the end, so the way we do safe today is controlling people's behavior. But we have to understand that behavior is not the problem. It's just an expression of the problem. If you have something behaving in a way that you don't like as a leader or So then take this as an information that perhaps this behavior is being facilitated by the organizational culture or the way the work is organized over there. So the context says a lot of things about behavior. Which context you have in our system that allows such behaviors to happen? So then let's to fix the context. But to be able to fix the context, we have to go up into the organization and try to take a look on the organizational culture. We see how the organization culture is facilitating this context that we would like to avoid. And then we may have a different behavior, okay? Behavior is the consequence of the real problem. So if you do not control people, how can we improve human performance? Well, we can stop blaming people for making mistakes. I said that making mistakes is human. So let's stop blaming people just for being humans. Okay, when we start doing that, so we will look the world in different way. So new paradigms will show up. So then when you realize that, we can start learning about normal work with our people, because we will be able to create a different environment. So by doing that, we can make the right way the easy way, because sometimes the safer way is the most difficult way of doing things, which is an open door for people trying to do something in terms of trying to gain efficiency, and an accident can happen. So let's take a look on that together with people to find a way to make it easier to do the right job. So, and then interacting with people will be able to fill up the gaps, the knowledge gaps that you identify. So help people to better negotiate these goal conflicts in a daily basis. And one of the most important things, identify and remove these error traps that can lead us to make mistakes that are there just waiting us to do something. And add controls that even allow us humans to fail safely. Even if you make a mistake, even if I fail, it doesn't mean that it may have to result in an accident or a loss. So in other words, let's make the system conform to people, not the way around, the way we are trying to do up today. Okay, let's do differently from now on. So, but this is only possible if you start to rebuild or create safety. If you never have safety trust, if you never have this in our system. So then with trust, so we'll be able to learn, effectively learn from the problems we have in our system, and people definitely will be much more engaged. So they will feel themselves accountable for their own actions. So this is the way you want to build a system in the future. So, but we have to start right now if you want to achieve something else. In Petrobras, just to give you an idea, so we have started a few months ago what we call human factors journey of Petrobras. So in this journey is 5 steps. It's not different from everything else you have in the literature. So in any journey aiming at to incorporate human factors principles and concepts into the way we do things around here, we have to start with leadership engagement. So then we have a big problem, how to engage top leadership in the organization. The second step is to build fluency among the entire workforce, contractors and the operator and politicians, regulators, manufacturers, and everybody else must understand the meaning behind these principles and concepts and understand how they can influence the way we do things in terms of improving our safety levels. By doing that, so then we can start trying, these new concepts. How can we use these new concepts in a daily basis in our activities? That's what we call operational learning. It's quite a long process. Okay, the moment we will learn something, how can we adapt things that, for instance, aviation does or nuclear power industry does? So how can we adapt to our industry and try it and see that it works or not? So then we can align and integrate the entire system. So procedures, regulation, human resources, selection and training, everything else. So in the industry. So at the end, we'll become much more resilient. And this is a never-ending process. So this is a loop that you have all the time do together. Just to, if you are interested, so in this issue of drilling contractors in May, June 2020, there's an article I wrote for the magazine, explain a 4 years pilot project we had in Petrobras and how to use human factors approach, to improve safety and performance in deep water drilling. So this is something that you can easily find in the internet, in the Google. Okay, and there's no other way of trying to understand most of the principles and issues that I brought today in this presentation than learn, study. There are big, wonderful literature behind of everything that I have presented to you today. So as I said, so I will send this recommended book list to you if you are interested in go deeper in this subject. Thank you, everyone. And now we are open for any questions that you might have. Thank you very much.
Thank you so much, sir, for this informative session. So you really made us change the mindset we have about safety system, especially that we are students and we have this option to design to not make errors. So basically, you change the mindset from human make errors to human art solutions. So thank you so much for this.
Thank you.
So let's jump to some questions. So I will start with the first one. So even if people follow all the rules, human mistakes and errors still happen either due to negligence or lack of situational awareness. When that does happen, should people be held accountable for their mistakes?
Okay, so the very first principle of the new view is that nobody comes to work to do a bad job. So if something appears to be a negligence of lack of anything, it might be a story behind that. Why it happened? So whenever you investigate anything, we cannot finish when you find that something made a mistake. Either name we use for label the mistake, negligence, complacency, or lack of anything, okay? So when you do that, you realize that most likely there's an explanation for that mistake that is inside the system. But of course, this is not a blameless approach. So there's sometimes that if someone goes beyond the tolerable, so then something else must be applied. The problem is how to define the thin line splitting what is tolerable from what is not tolerable. Okay, this is something that must be negotiated in between the workforce and the leaders within the industry to allow everybody to really understand and know which behavior is tolerable and which behavior is beyond the tolerable, is not tolerable. So then we can apply what we call just culture. Okay, so then even these words, negligence or complacency or violation or something, is much more related to a criminal investigation than an accident investigation where we want to learn. In a just culture, we have to choose. Either you punish, you find somebody to blame, or you learn. Both cannot work together. Okay. But this is something that is not easy to explain very quickly. So in that book list, you have some books that with very interesting approaches on that. One of them is called Just Culture, written by Sidney Decker, that will deliver much more information about this question you just made. Thank you.
Thank you, sir. So second question is, why do operators often become complacent when it comes to safety, leading to them not following the procedure?
Okay, complacency is a choice, is an individual choice. We individuals, we choose to be complacent. This is a very tricky question. This is something that we have to reflect on that. Nobody chooses to be complacent. So when doing something that on our eyes after the event, in hindsight, we see as a complacent behavior. So again, we have to try to understand why such a behavior happened the way it happened. So then it's much more complex than just find someone to blame, because all of us sometimes will be, from somebody else's eyes, complacent. All of us will always be, from somebody else's eyes, negligent. From our eyes, we have an explanation why we did the way we did. Okay, so then this is something tricky. It's a big shift in our mindset. You know, when you see people as a problem, logically, you find every behavior that you do not agree as a threat to a perfect system. When you realize that people are most of the time resolving problems you have in our system, and we don't see that, so then we'll blame people. When you don't see that people are resolving problems most of the time. The same behavior that resolved most of our problems sometimes may result in an accident. And then we'll see, and you say, oh, you did differently. You didn't follow the procedure. So that's why we have an accident. This is totally false. This is a fallacy. By not following the procedure, most of the time, if you try to learn from the normal work, you see that because of that, we succeed. You know, the Murphy's Law in a complex system is totally wrong. The Murphy's Law says that if you have one single chance of having something going wrong, that is going to happen this way. Actually, it's the opposite. We have thousands of opportunities in the daily basis, you know, to have things not going right. And even though they went right. Why? Because of the human participation, the human contribution. You know, they resolve most of the problems in a daily basis. So that's something that is quite tricky. It's not easy to swallow in the beginning, but the moment when you decide to go deeper into that,
setting the procedure.
sorry, say again.
Can we automate human error out? Can we automate human error out of the system when setting the procedure?
I mean, you mean?
Yes, I think so. It's
automation will take the rule with human beings as a support to the automation, or on the other hand, in which extent, you know, humans take the front line in the automation or technology will support humans. So, of course, there's some limits that is very easy. For instance, whatever is very repetitive, simple task, we better, you know, to have it automated instead of having human beings doing that. The problem is when you are in the middle, okay, in which stand, you know, the human decision in a very critical situation is required. If you automate too much, for instance, in the FPSO operation and a production and the storage platform, okay, the operational center room in there. So if you have an operator doing nothing, just taking a look on the screens, the moment something goes wrong, most likely the human being will not be able to intervene in time to resolve the problem. So then you have to find a balance, and how can you keep the human being even operating, you know, to be ready the moment the algorithm cannot resolve the problem we have. Remember what I said, the reality is richer than we can think. So sometimes something may happen that is not there in the algorithm. So in this case, you will need the human being, you know, to take the front line and do whatever must be done. So, but that's a very old discussion, and more recently, there's a discussion between human factors and human reliability. So there are some people that think they are the same thing. Actually, they are let's say, the approach is quite different, if not opposite in some aspects, because if you in the human factors scientific field believe that error is part of the game, error will be there, so then we better accommodate our system with this reality that error is there. So it's totally different from approaching in another way that's fix the humans to make them not to commit errors, to be more reliable, and then we'll have a more safer system. So they're at the end, they are saying opposite things. They are not the same thing, okay? There are some scholars like Sidney Dekker or Andrew Hobson that claims that human reliability is just a kind of a revitalization of a behaviorism, the old behaviorism that blames people for everything wrong that happens in the system. This is an old thing that human factor is trying to get rid of over the last 40 years of research.
Thank you, sir. So the first question is how we can understand the human errors and we can say daily basis work in order to design it in a human factor aspect.
Okay, that's a wonderful question. So how can you learn? That would be the broader question. How can you learn from the normal work, the routine work on a daily basis? So there's no other way. We have to interact with people because they are the ones that know the problems we have. And most likely they might have the solutions. The problem, we don't ask them. So the leadership don't ask them. So what the problems are and how can you resolve the problems? They know, but we don't have the environment for that. So then you have to create the environment. And the very first thing we have to do as leaders is find a way to regain trust. The moment we regain trust is not easy. So then we can work together with our people to find out what the problems we have in our system and start fixing them and eliminating them. This is an art. The IOGP, together with SPE, is about to launch a report helping us on how to learn from the normal work. So I think that is the very beginning. By doing that, so then we'll be able to start fixing the deep problems we have in our systems to improve safety, effectively improve safety.
Thank you, sir. The next question is about the time constraints. You mentioned the time constraint when you talked about the new system or the new view of system. You mentioned the constraint basically about the new approach. When you talk about the new approach, the people are solutions.
Yeah.
You mentioned the time constraints.
This is the answer for this. This is $1 million question. If I had the answers on how to overcome all these constraints you have in our industry today, so that I will become rich. But yes, definitely we have to start with the top leadership and the top leadership of the main operators, because the main operators, they lead it, the whole industry. Okay, and this is happening today. So 5-6 years ago, some of top operators have realized, and Petrobras is one of them, realized that we cannot continue doing the same thing or doing more of the same. We have to find out something different to be done. And then it was easy, when looking outside and to see that, oh, there's a different approach proposed by the human factors scientific field. So let's take a look on that. And then the moment the top leadership of this organization start to understand, and not only understand the value of adopting human factors principles and concepts, but also realizing the difficulties we'll have ahead, okay? Because it's not a matter of a credo. I believe in that and that's it. No, we have to be very professionals and then see that is not an easy task, because the mindset that you have today has been created over the last 100 years. So how can you change a mindset overnight? It's not easy. So this is a long journey, a long journey. That's why we say that we need to start with the top leadership. Because without the sponsorship, and more the sponsorship, without the engagement of the top leadership in the oil industry, nothing's gonna change. So that's the very beginning. And the second is doing things like we're doing today, spreading the news, allow more and more people to be more familiar about this different approach. Is a totally different set of paradigms you are proposing to incorporate into the old paradigms, so then we can start moving ahead from a safe industry to an ultra safe level of industry. So, but the most difficult task to overcome the constraints is the old mindset in very hard heads, especially old guys that are now occupying in the top positions of our industry. That's why it's very important to talk about that to young people that will lead the industry in the future with a different view, with a different way of dealing with the problems we have today.
Thank you, sir. So the last question is about, do you think that we are able to design, we can say, a data-driven system that basically uses artificial intelligence to capture these human error traps that you talked about in order to improve the human factors? Discipline, if you can say.
Yeah, whatever tool we can use is very welcome. I know that there are a lot of research on that, to try to capture human errors and try to understand why the human error is happening. The problem is we very easily can skip from trying to support people to go back to controlling people. Okay, this is some tricky issue. So we have to be very careful when bringing technology, originally thought to help people to overcome, their own errors, and use the same technology to go back and keep controlling people and punishing people and replacing people and so on. So then you have to be very careful. For instance, if you have a car, modern car, expensive car, fancy car, with some sensors that advise you when you are tired on the dashboard, so some lights blinking or something. So this is good because it's alerting me that I may commit a mistake because I'm tired or I'm not enough sufficient prepared to continue driving. So then I better stop, take a coffee or take a rest or something. This is good, but imagine that the same technology is used to inform the police at the roadside that I'm tired. So that is something that I wouldn't like to have. So normally people, what we do is disconnect the system because they don't want to be, blamed as a criminal because they are tired. So this is a different way of using the same technology. So it's important, but we must be careful. I myself, I rather prefer using a very old-fashioned way. Just talk to people. Listen to people, actively listen to people. So, and then we will figure out where these error traps are placed, and then we can, together with them, identify and eliminate these error traps.
Yeah, it's all about human interactions, as you said.
Yes, that's all about human interactions. That's why I said in the beginning that the human factors is very naturalistic. I didn't use the word, but the idea is that. And what human factors proposes, let's bring the human beings back to the game. Because if you see the old way of doing safety, we separate things. We have the system, great, and we have the people. Ooh, so as they are two different entities. Okay. For instance, today there are a lot of people still talking about safety culture. I think that I don't know what means, because safety culture cannot be split from the organizational culture. So it gives an idea that safety is something separate from the organization. When safety is over there, safety is an emergent property of the system. Safety is not something we have. Safety is something we do in a daily basis. We never have safety. Safety is created in a daily basis by people.
Thank you so much, sir. So we learned a lot from this presentation and how we shift basically the idea from control, as you said, control safety to management of safety. So thank you so much for being us today. Thank you for the audience to being here.
Thank you for the
We
opportunity.
hope to see you another time.
Okay, and as I promised, I will send that book list and some references for whoever wants to go deeper in this subject. So it would be great.
Yes, we will ensure basically to spread it to all the audience here by email.
Okay, thank you.
Okay,
Thank you
thank
very
you so
much.
much. Have a great day.
You too. Bye-bye. Thank you.